So, are we there?
Yes, sir.
Okay. So this is it. Yeah. After that, after getting the area here, volume of growth chamber. You know what the volume is? The volume now, you know, the greenhouse does not have, and this rafter does not have a ceiling. Hmm?
Yes, sir.
Okay. So let me ask you now. Someone should calculate the volume of this, of the rooftop now. Can someone calculate the volume of the rooftop? Back now, sharply. Someone should calculate the volume of in short, the volume of the whole greenhouse and send to me now. All of you should calculate that and send to me. If you're consulting the PowerPoint I sent to you earlier, the calculation in that PowerPoint is wrong. Hmm? You people should note that the greenhouse has two parts. The roof and the body. The roof and the body. Huh? So if you have the roof and the body, and you have the height, you have the width, the length, and you have the width. So what's the volume of the rectangular structure of the greenhouse itself? That is going to be, volume is what? 770 times 550 times the height 388. Right?
Yes, sir.
Okay. So now if you look at the roof, how do you calculate the volume of the roof? Hmm? I'm waiting. I'm waiting.
Area times height.
Area times height.
That's the volume of which part is that?
Volume of the roof.
Of the roof. Which is the area? So what do you have?
Sir, please, we are not seeing the slide, the screenshot of the picture.
Okay.
Thank you, sir.
9 million.
That's not the bill.
Someone, okay, is okay. Are you? Is that okay? Is that okay by everybody? Is that correct? Say the area times what?
times height.
What's the answer? Area times height. What's the answer? Oh yeah, now. Oh yeah, now. Oh yeah, now. Oh yeah, now. What is the answer now? Area times height. What's the area times height of the roof? Hmm? Someone should talk. Hmm? 770. Are you not sure? Huh?
6.97 times 10 to the power 9.
6 what?
6.97 times 10 to the power 9.
What and what did you multiply to get that? What and what did you multiply to get that? Talk again. And talk. What and what did you
So
multiply?
area of the roof.
Okay, is what?
So, I'm going to multiply the length of the slanted side of the roof
Uh-huh.
with the length,
Okay.
which is 770 mm.
Yes.
So the area of my roof here is 440,755.7 mm square.
Okay.
So and the total area of the greenhouse, we're going to add the area of the walls, the area of the end walls, the area of the side walls, and the area of the roof.
Yeah.
So
Yes,
and
we have done
Sir?
that. Well, what we're looking is the volume of the roof.
the volume of the roof is I want to multiply the value of our B, that is 550 mm,
Uh-huh.
with the length 770 mm.
And what?
And I think the half of it, that is 1/2 is 0.5.
What are you saying? Half of what now? Eh? That lady, what that lady said something. What did the lady say? Lady, you said something. What did the lady say? Where is she? Talk.
Sir, I said area of the roof.
Yes.
Area of the roof multiplied by the small h.
You can't be multiplying it twice now. You've used that small h in calculating the area of the roof. So will you be multiplying it twice?
Sir?
Yes.
When calculating the volume of the roof,
yes,
we're going to multiply with the U, that is 0.58, sir.
Why would you multiply by this? What are you saying? No. Do you know what? Everybody sketch.
Sir.
Yes.
Sir.
Okay.
So the thing is that we will combine the volumes of the roof and the surface of the body. So when we calculate we calculate two volumes and we'll add them together. The first volume is for the roof. That's when we use the area of the roof plus times the height.
Wait. Area of the what is the area of the roof now? Show me. Which values are you multiplying on the screen? What are you?
Area of the roof is what? Wait. Half times. So the area of the roof is going to be half times the, what is called it? The base times
is
the
what?
height.
Yes, very good.
That's 0.5 times 550
Wait,
times 770.
relax.
Okay, sir.
That's what I said.
Wait, now, okay, you want to cut, this is the area, okay, what are you going to multiply to convert it to volume?
So the area will multiply it with the height of
Which
the, what
height?
is called it, of the roof. That's going to be 158.6.
You have
That's
used
the height of the roof.
158.6 before. No. You calculated the area before as 550 times, it's not 158.6. Or what did you multiply
Okay,
with?
no, it's going to be the length and the breadth.
Uh-huh.
Half times length times breadth.
Uh-huh.
That's going to be the area. That's what we are going to use for the area. Then the height will now be that 158.6 that we're going to use for the volume. That's how we're going to get the volume of the roof. Then for the volume of the, sir, do you get that part, sir?
No.
So if we want to calculate the area of the roof, we'll use the length and the breadth times half. That's 550 times 770.
You are getting
half.
this thing. Wait, you are getting this thing wrong. You are seeing the screen now? Are you seeing answer now?
Yes. Yes, sir. Yes, sir.
Yes,
Okay,
sir.
now this roof, it has 3 parts. Agreed?
Yes, sir.
The right triangle, we have it one at this end and another one at the other end. True or false? Answer now.
Yes, sir. Yes.
True, sir.
Eh?
True, sir.
No.
Yes, sir.
Who said no? What is the base of the triangle, of this triangle? Draw a triangle, draw a right angle triangle. The base is what? 550.
550.
And the height is what? 158 point what? 0.6, right? Now, do we know the slanted length? No. Let's calculate the slanted, look at, write L as the slanted length. But let's calculate the area of this triangle. What is the area of this triangle? Half base times height, is it not? That's 1/2 times 550 times what? 158 point what? 0.6. This is, remember, this building, we have 2 of the triangles, one on this side, one at the other end, right? Are we understanding me?
Yes, sir.
Yes, sir. Yes, sir.
Who is saying I again? If you don't understand something, say it. No talk again, no. So area of one of the triangles is what now? That's 5, that's 0.5 times 550 times 158.6. That is 43.6, sorry, 43,615. Then there are 2 of these triangles. The other one is on the other side, down the road. That's times 2. Times 2. What do we have now? Area of the 2 triangles is 87230 mm squared. Agreed?
Yes, sir. Yes, sir.
Okay. Now, on your triangle, now, since you have separated this roof into 3 parts, 2 triangles and 1 rectangle. Abi? And the rectangle now, the longest side of the rectangle is what? 770. The short one is what? 550. So what's the area of this flat surface now? That's 550 times 770. That is what? 423,500. Plus the former one, 87615. That's 511,115 millimeter squared. Right? Are we following me?
Right, sir.
Okay.
Yes,
Now,
sir.
to get the volume, to cut this thing short, look at this diagram. You know that this is like half slanting a rectangle, like a matchbox by the diagonal. This is the roof. Do we understand?
Yes, sir.
Yes, sir.
Make this roof now a matchbox and you cut it across. You're going to have this shape. So the easiest way to calculate the roof of this nature, the volume of this kind of this kind of shape, just complete the this thing, the box, complete the matchbox. If you complete it, what are you going to have? You're going to have a rectangular matchbox now, is it not? Volume of a matchbox.
Yes, sir.
The volume now will be what? If you make it a matchbox, the volume will be 550 times 770 times 158.2. Do we get? But now we have divided this one into
Yes,
2.
sir.
So now divide it by 2. So the volume of this roof now is what? 550 times 770 times 158.6 divided by 2. Volume, that is 33583,550. Are we there? Is it okay?
Yes, sir.
Yes, sir.
Okay. If it's not okay, we should just go and learn it. I look at this. Look at the screen now. Is it making sense? Okay. Okay. So next slide. Heat loss by infiltration. You can't see the formula. Let me bring it down. If this introduction like this is difficult, what about when we go to the main thing? This is just to introduce you guys into. Why is this now? But this is heat loss, infiltration heat loss, right? Which is Q. We know our C was given to us as what? 2, right? We know the volume of the greenhouse now is going to be the volume of the roof plus the volume of the what? Of the rectangular block of the greenhouse. Specific heat, we have the specific heat, and we have our delta T, which is T0 minus T1 to be 25 degrees, right? So you guys should complete the assignment. Finish. Hello? Are we there?
Yes, sir.
You guys do it. Okay, let's go. Another look at this. This is a class. This is for classwork and to be submitted in the next 5 minutes. This one is classwork to be submitted in the next 5 minutes. Example 2. Let's go. I'm waiting for answer. I'm waiting for. I'm waiting for your answers. I'm waiting for your answers. Example 2. I want to have your answers now. This is 9:45. In the next 5 minutes, 9:50. Oh yeah, oh, I'm waiting. Why is this thing on this stand instead of it to hide? Says calculate the heat loss in a greenhouse if the southern fully glazed and northern completely insulated area is this and this respectively. The average ambient and greenhouse temperature for the year is 32 degrees and 20 degrees Celsius in that order. Assume R value for the glazing and insulating material is this and this respectively. Heat loss by infiltration loss to be what? 1/6% of heat loss through the glazing. Calculate the heat loss in the greenhouse. So which of the heat, first, which of the heat losses are you to calculate?
Through the glazing material, sir.
Which of the heat, they have names now. Which heat loss are you calculating?
Of conduction, sir.
And what are you saying now? Okay, conduction, okay. Heat loss through conduction and what? And infiltration.
Yes, sir.
All right, let's go. What's the answer? Some people are running away to go and check this thing. Okay. And sure, don't waste our time. Look at it here. Look at the solution here. Look at the solution. Very straightforward. Are we following?
Yes, sir.
Yes, sir.
All right. Okay. All right. So let me show you something before we go to. Okay. Before we go to the benefits of this new slide. Okay. Okay, I'm coming. I want to show you guys something. Meanwhile, while that is trying to open, let's look at the next slide. It says what? Benefits of what? Of greenhouse agriculture. Benefits of greenhouse agriculture. Number one is the one benefit says what? Possibility of cultivating crops outside their what? Normal growing season. Right? The possibility of cultivating areas such as the desert which are not suitable for open field agricultural practice. Now, who can tell us the first point, the first 2 points? What do they mean? because they are similar. The first 2 points. Who can explain to us the first 2 points? Please, please, please. You guys were supposed to have read all these things now. I told you that we are coming here to, not to come and, for you to come and be looking at me. Huh? It's for us to come here to discuss the possibility of cultivating crops outside their normal growing season. What does that mean?
So what it means is that since we are going to be cultivating inside the greenhouse and we can easily manipulate the climate season conditions inside the greenhouse, thereby like we are giving our crops the essential nutrient they need in terms of relative humidity, temperature, and the likes. So we can regulate that inside the greenhouse. Thereby, we can cultivate, even if we are in a dry season, we can cultivate with the same conditions, same climate conditions relating to the rainfall seasons. We can do that as long as we are growing inside the greenhouse.
Okay, the second point, it goes together with that.
Yes, that goes with the arid and desert areas or hot areas. Since that there is no water there or there is very much heat temperatures, with that inside the greenhouse we can regulate those things inside the greenhouse.
Yeah. Okay, good. The next point, better utilization of sunlight and higher accumulation of carbon dioxide. Point 3. Class rep, Finn, over to you. What does, explain to us point 3, what point 3 means?
Okay, sir. In the greenhouse, you could regulate the sunlight you are putting in and the amount of carbon dioxide you are taking into the greenhouse, because you can regulate it so that it's the perfect amount of sunlight and perfect amount of CO2.
You said what? I didn't get it. Come again.
Okay, better utilization of sunlight and higher accumulation of carbon dioxide. In the green, would regulate the amount of sunlight that comes in and the amount of CO2 that comes in.
How? How do you regulate? How do you utilize better sunlight better inside? So it's okay. Okay.
For CO2, it's possible for you to bring in much CO2 from, I think there are pipes you passing through the greenhouse. So it's possible for you to bring that into the house.
Is it not okay? You're not answering this in the way I want. Like, okay, that's your own this anyway. Okay. Wait. Okay. It says better utilization of solar radiation and higher accumulation of carbon dioxide. You know what I say? It says better utilization. Now, look at this. Your environment is enclosed, right? And at the same time, better utilization here is not referring to the fact that you have you are going to have more light in the greenhouse than in the outside. No. You know why? It's because your solar radiation, as it's coming in with heat, right? It's coming in, and since your environment is sealed up, there's going to be what? Heat build up within the greenhouse. So you are receiving solar radiation. At the same time, your solar radiation is heating up your greenhouse. That's what it means by better utilization of solar light. Not that you're going to have more solar light within the greenhouse than outside. No. That's your solar radiation is going to provide light, at the same time, it's going to provide you with heat. And then higher accumulation of carbon dioxide. Since your environment is sealed up, there's going to be what? CO2 buildup. And aside CO2 buildup within, due to the fact that your environment is enclosed, you can introduce CO2 in your environment, which is not possible in the open field. You cannot increase CO2 outside. Wind will blow it away. But since your greenhouse is confined, CO2 will stay within once you introduce it. Point number 4, optimization of water use. Optimization of optimal use of water by the use of drip irrigation. That's straightforward. Yeah, this one says protection of crops against insects. Yeah. That's straightforward. Protection of crops or cultivated crops also from harsh temperatures, this, there. That's straightforward, simple and straightforward. Greenhouse effect reduces crop production. Good. Point 7. Point number 7. Someone should explain that to us. Point number 7.
Yes, sir.
Hello.
Okay.
Good afternoon.
Point number 7. Yes.
Since the greenhouse protects the crops from bacteria, from insects, there will be no need to buy all these insecticide, herbicide, and all, since it's protected from the insects and atmosphere, flies and all. So it will reduce the cost of buying all those insecticides to just probably waste money. So it will not it will prevent you from wasting money on buying all those insecticides.
Yeah. All right, that's true. Exposure to chemicals is reduced. Okay, exposure to chemical toxins associated with application is minimized. Yeah. Okay, then disadvantages, costs. That's the initial investment. Initial investment is huge, right? So many people cannot afford. And then durability. That takes you back to factors and considered in farm structures design. Let's look at it. Good. Let's look at this. Design considerations of farm structures. No, very good. This one, characteristics of our farm structures. Design, construction, and technology. This, strength and safety, expected service life. You see? So let's look at these characteristics of farm structures now. Assume you want to design You are given a contract to construct a greenhouse. And look at this. First thing, what are the questions you're going to ask? Is it a standalone greenhouse? If the answer is yes, that's the design and construction technology. Look at it now. Is it a standalone? Is it a gutter connected? Or it's a lean-to greenhouse? If the answer is yes for standalone, that's the design. Then, let me even separate this construction technology. If then, construction technology, how do you want it? On the site, is the site such that you can do on-site or off-site construction? Materials of construction. What materials? What is the budget of the investor? Can he afford to go for steel? Can he afford to rather, or will he rather prefer aluminum pipes? Materials of construction. Strength and factors of safety. What is expected? Is it just greenhouse alone? Do you intend, does the investor intend to expand or divert into something else, like from greenhouse to plant factory? What is the expected service life? How much loan has the investor taken from the banks? And how soon is he expected to repay the loan? That will determine how much, that will determine what the expected service life. And they will now say, okay, I'm paying back in 10 years. That means whatever structure, whatever design, whatever material of construction, and the strength and factors of safety taken into consideration must be such that the greenhouse structure or whatever structure they are designing will last for 20 years for the investor to be able to recover his investment, return on investment, and then profits, get back his investment with profit. Ease of alteration. Does he want to, after getting back his money and making some profit, does he want to now change that structure for something else? Or does he still want to continue with that same farm activity, and then aesthetic, which is beauty, right? Are we here?
Yes,
Yes, sir.
Yes, sir.
yes, sir. We are with you, sir.
Okay.
Yes, sir.
All
Yes,
right.
sir.
It's okay, it's okay, it's okay, it's okay. Before you come and definitely with yes, I guess. Okay. So next thing, let me just do a brief introduction. Will this one? I want to. Wait. Let's stop here for today. Let's stop here for today.
Yeah, thank you, sir.
Meanwhile, hold on. Oh, where's this? So, you guys should hold on. I'm not yet done. I want to. Okay.